This lecture is going to talk about commercially available soil health tests. And we're in an era right now where there are a number of tests that we can talk about, or a number of different frameworks, but we're still um, relatively early in kind of the trajectory of this. I think that as time progresses in the next several years, we're going to see more and more things come online, okay? And in no way, I guess, is this intended to be comprehensive in terms of what's out there, right? But just some of the maybe more common ones, or at least early adopters. So we can start by asking this question: why do growers need soil health testing? I would argue that in addition to this, like if we don't measure it, we're not going to be able to manage it. We need a more integrated approach to nutrient management. The tri-state fertilizer recommendations that we've talked about, soil test P&K extractions, the vast majority of nutrient recommendations, fertilizer X, are based on chemical extractions of soil that largely ignore the biological potential of organic matter mineralization. And so when we think about or if we start to integrate, or we think about a framework where we might integrate biological activity or biological performance into nutrient management, we can think maybe of increasing or decreasing rates based on that. So those are frameworks that are trying to be developed right now, but to my knowledge, there's nothing that's really scientifically sound that's come out in that arena. But that's certainly a long-term goal where we want to go. This is all in the context of avoiding over or under applying fertilizers, right? We want to use additional information to better manage our inputs from a farm profitability perspective and from a nutrient use and soil and water and atmospheric quality perspective. A lot of over application of fertilizer. Farmers often get demonized in terms of, oh, well, they just like throw it on, they're just dumping nitrogen on, they don't care, they don't know. That's a really short-sighted view. It's not the reality. The management is incentivized, and it's about risk. It's about mitigating and managing risk. And a little bit of extra nitrogen fertilizer in many ways is viewed as an insurance policy, right? And or a little bit extra phosphorus, or a little bit extra this or that, right? So when we have uncertainty, and certainly in the case of relying on organic matter mineralization brings inherent uncertainty into this. But when we have uncertainty, we need that uncertainty is going to increase the risk to growers, and so we need tools to help account for these risks, right? So if we want to truly reduce reliance on external inputs and help foster biological synergies, these plant-soil microbe interactions that we were talking about in the last lecture, we need tools to be able to account for that, manage it, and understand that system better. So I would say that these are really important reasons or justifications for why we need soil health testing, okay? So I'm going to talk just a little bit, and again, this is not comprehensive. This is the things that I'm aware of, and there's probably other things coming online, et cetera, et cetera. But these are really the main players to date. So we have a self-assessment in the field with an NRCS kit. We have several commercial labs, and we have a couple university labs. Again, I haven't recently scoured to see what's out there, but this is this is what I've encountered in my time, the last numerous years working in this field. I'm going to start with an NRCS soil quality test kit. This is an in-field kit for assessment. You can purchase it, or you can assemble it yourself. And this is really more about a hands-on assessment and demonstration. It's more an educational piece than it is actually, taking a really precise laboratory measurement. This was released in the early 2000s, and it's really kind of the first kit that was out there, and maybe that soil quality and not a soil health is representative of the time frame upon which this was released. But they've got manuals and some interpretation. So it is a nice reference in many regards. But farmers, aren't going to come out here and do this themselves. It's more of like more of an educational piece. So that's an important thing. And here are the components to them. And, this is really just for reference. Texture, there's a number of physical pieces, there's a number of biological pieces, and then the chemical piece. So an excellent educational tool, but not something that, say, most farmers that I know anyways, are going to go out and mess with intensively, etc. Okay, we've already talked a little bit about Cornell and their soil health framework. This is, again, in my opinion, really leaders in the soil health field, and we're kind of pioneers in terms of thinking for a long time and devising and coming up with the soil health test. Okay, it's gone through a few iterations over the years. Everything is essentially lab-based, so we realize farmers don't have time or expertise, or oftentimes like super interested diving down and getting the nitty-gritty of details and measuring this or that. They want to sample soil, mail it to a lab, and get numbers back, and that's exactly what this service provides. Okay, so they are 3 different scales to test depending on what you want to get, and there's physical, biological, and chemical tests here. The basic package includes these indicators: aggregate stability, surface and subsurface hardness, respiration, organic matter, and then a standard nutrient analysis of P, K, and micronutrients, pH, pK, and micronutrients. Okay. Cornell Framework relies entirely on scoring functions. Okay, and so these are the framework where they've taken lots and lots of soil tests that they've analyzed over the last 15 years, and they rank them in terms of value. And so, say from a value of 0 to a value of 550 or 800 or whatever the number is, depending on the indicator. And they develop these kind of cumulative distributions. So 20% of the samples will be from this value to 0, the next 20% from that value to this value, using this cumulative distribution. And then depending on the percentile that you fall out in, you'll get a red, orange, yellow, light green, or dark green score. So depending on the measurement, for example, something like I'm just thinking like respiration, soil respiration, for example, more would typically be considered better. So if your respiration values are way out here, you're going to get like a, A+, super good job there. Some values are less is better. So if it's, say, a disease indicator or a disease load, if you have very little load or very little disease pressure, then it's going to score well, but if it's really high value, it's going to score poorly. And then there's an optimum, so we don't want really low, we don't want really high. pH is a good example of this, where very acidic or very basic soils are not what we're after some kind of optimum. So this is really how they kind of generate the interpretation. It's a pretty rudimentary way to do this. But they've done it based on their large data set, and since they've been here for a long time and kind of doing this for a long time, they've got soils from all over the country. There's been some, there's been analysis that have been across all their soil samples across the country. There's been more regional analysis that have done where they look at the Mid-Atlantic, the Southeast, and then the Midwest, for example. So, there's nuances in terms of how you actually generate these scoring functions, but this is an important part of their framework, okay? And then when you get a Cornell soil health test back, you've got physical, biological, chemical indicators. You've got the actual soil test value. So maybe for like the case of phosphorus, it's a 17 part or 18 part per million. And then it's going to rate that. And here's where the indicator function, that scoring function, comes into play. So this is a scale of 1 to 100. This scale this is like, each one of these has a different unit. For example, like subsurface hardness, that's a pounds per square inch. Organic matter is a percentage, et cetera, et cetera. And then here's that scoring function. And so I like this example because it's representative of what they find many times, which is that the chemical piece all come out relatively good. And it's because we have standard methodology for measuring this. Farmers are used to tracking. If their pH is low, they add lime. If their phosphorus is low, they add phosphorus, et cetera, et cetera. And we end up getting really good scores with the chemistry. But the biology and the physical structure, that's where, we often need work. Okay, so this is an important component of kind of their framework. Okay, so we also have more locally in Ohio, we have Brookside Labs. And Brookside, they run a number of different soil health tests that they offer. Theirs is really based on a lot of kind of what we would call, like Haney test or Haney framework. And so we have a Solvita test, an extractable carbon nitrogen, and total carbon nitrogen. So they run this, and this is in New Brennan, Ohio, so Auglaize County. And the scores that they provide are right here. They sum this all into a soil health score. So this is your score of low, or bad, low, medium, and high. Okay, so they've got I'm going to show you a number of different examples, starting with this one, starting with really the Cornell one, to show you different approaches, just to give you a flavor for it. So all the details aren't all that important, but this is a Woods End laboratory out of Maine, and they use Solvita test and then Haney extractable nutrients. Again, they've got different things that they measure, and they rate these in red, yellows, and greens. So that's a common thing, that soil testing labs do. They give you an overall fertility score, an overall soil health score. So how do they define those things, and what does that mean? Well, it depends on the lab, et cetera, et cetera. Here are the measurements that Wood End Labs use. And here's how they actually define the soil health score. So it's made up of respiration, this amino nitrogen, and aggregate stability, and organic matter, and then a water-soluble organic carbon or water-extractable carbon. They take these. This is, in my opinion, this is, a lot of, there's a lot of uncertainty in this factor, right? So we can and we can generate values for each one of these things. But then how we actually weight them and score them and what's good and what's bad, that's where a lot of this uncertainty rolls in, okay? And so for this example, here's the expected value, the test value, here's the score. Then they weight this. And so, for example, some of the tests, like respiration, get a factor of 1. Amino nitrogen gets a factor of 2, so it's worth twice as much as respiration. Soil organic matter is worth half as much as respiration and 4 times as much as amino nitrogen. So, this piece right here, there's not much literature that demonstrates where these numbers come from and how they're generated. So is it a good estimate? Well, likely. But is it really rooted in science and vetted and all these things? To my knowledge, I would say the lion's share of this is not. Do we have to start somewhere? Well, absolutely. And are we going to revise this and move forward and figure out better new ways to do it? Well, likely. But we just have to be careful on how much stock we put in this, okay? And so, here's our score weight, and there's different ways that, this might be calculated, okay? Here's a comparison of the ones I just discussed, the soil quality, from USDA, the Cornell Soil Health, the Woods and then Ward Laboratory, which I didn't get to, but again, they have a different scoring function. I'll just show you an example of why it's a bit of the Wild Wild West out there. We took a soil it's a Hoytville clay loam from Northwest Ohio that was organically managed for about 20 years. We would consider it a very productive, healthy soil. We sent these to 3 separate labs that offer this, so the Cornell, the Woods End, and the Ward, okay? This is just a matrix saying kind of the relative or the numbers that we get from each one of those, and then you can see, like we just observed, that not all of these frameworks use the same indicators or the same measurements in them, okay? But at the end of the day, they gave us a soil health score based on the property. So Cornell tells us we're 76 out of 100. Woods End tells us that we're 31 out of 50. So we multiply that by 2, that's 62 out of 100. And then Ward Lab tells us we're 17 out of 50. We multiply that by 2, and we're at 34. So 76, 62, and 34 out of 100. That's as a percentage. So, well, there's a big difference between 76 and 34%, right? And so, again, it's like, what do these numbers mean, et cetera, et cetera? I would argue that the numbers here are very good and very meaningful. But when we go to compile and generate some single indicator value, we're really, in some ways, you venture into really, really squishy territory, very almost dangerous territory, I would argue. And it goes back to an early point with the overview that soil health is a multivariate enterprise, and it's a multivariate phenomenon. And we can't just boil all this down into one single soil health indicator score. It's just a misguided approach, in my opinion, because a 76 here might mean that we're really good with some of the chemistry and some of the biology, but our physics are it's compacted soil, for example. And then we might have another soil that scores a 76, and it's a 76 for very different reasons. So we need to look at these individual indicators and kind of consider soil management and best uses and best managed practices, not based on this indicator score, but based on what has gone into them kind of individually and then collectively. So, all right. So that's just a word of caution to not place a lot of value here. All 3 of these labs kind of came with recommendations. So soil management should aim at maintaining this functionality. These are just kind of quotes from the output or the soil test result. Cover crop suggestion, grass or non-legume due to high M, no lime needed. Cover crop suggestion, 30% legume and 70% grass. Okay, so again, different recommendations that come with these numbers. I tell people this quite a bit, but Cornell's done a really tremendous job in terms of creating a comprehensive assessment, not just a framework, but a manual that accompanies that. There's a lot in here. This is a free download as a PDF. I'll post this on the Carmen site, but there's a lot of good information here. It's really, in my mind, a starting point of a text. It's like an elementary textbook for soil health. So there's a lot of good information here. How we should think about soil health, how we can think about it in a productive way, and the different measurements. It goes into some, not a lot, but some detail in terms of the measurements that are there in the frameworks, and then what we can do to kind of improve low scores for some of these measurements. Okay, so I'll end there in terms of the available commercial tests. There's, again, plenty that I haven't touched on, but these are constantly evolving enterprises, so we'll have to see where each one of these tests go on an individual basis.